For the leads of your individual areas within the Navy, what's one unique end state of AM that you're after? What does the future hold?
I can start really quick. I think a lot of people when they talk about AM, especially in the DoD right now, talk about producing long lead time components and things like that. And it's because the DoD has a very unique use case in that area. We have legacy platforms that have been around for 50 years. Suppliers no longer exist. And so we need to produce components that look like the way they were traditionally produced in some cases. What I'm really interested in, what we're starting to see is our OEMs coming to us with designs that cannot be manufactured any other way. And utilizing the design space AM enables, these individual components perform better and in a way that no other manufacturing process enables you to do. And so what I'm looking forward to over the next few years is just a giant increase in the amount of components that are designed using the additive manufacturing design space, so we can get a performance out of those items that are beyond what we've been able to realize to date. And no matter, if you go around the Department of the Navy right now, amazing R&D in these areas, electronics, energetics, all these sorts of things. Seeing some of those designs come to the forefront, come to actually be fielded over the next few years is what I'm most excited about.
From the perspective of NAVFAC and the combat enterprise, one of the things I'm hoping kind of comes forth out of these processes over the next few years is new tools that will allow more capability to be done at the tip of the spear and less having to be done via engineering reach back. Right now, there's a massive amount of engineering reach back needed. We don't have rates and Navy enlisted codes for folks that are doing AM at the tip of the spear, and for the Marines as well. I don't think we're ever going to have a place where we're going to have a lot of engineers deployed in maintenance battalions to do this kind of stuff. But as we get more robust or tools, and we need tools just to be able to do like finite element analysis on AM type products with their anisotropic properties. As those come to the forefront and allow to push some of this engineering analysis to the tip of the spear, we'll get more and more able to respond in those distributed maritime environments. And hopefully, and with comms denied environments being an issue as well, the more capability we can have at the front line, the better off we're going to be. So to try to move this where it can be more self-contained, more portable for the engineering analysis and decision-making, I think is where I'd like to see this go.
So I'll jump in here. And by the way, Todd and Ben are spot on in terms of what we're talking about in terms of next generation capability. I think I'd like to take a step back and look at this, what this means strategically. If I had if we thought about AM in the context of overall capability and in terms of design through manufacturing, how fast could we go? Could we get an ACAT 1D new platform out in 5 years or less? Could we change our sustainment strategy so that we wouldn't have to spend the money that we do, but in terms of sustainment, and then reapply those savings to better capability development so that we can deliver things much more quickly and we don't have the costs associated that we typically have for major programs? I think that's doable. And so what that really talks to, though, is about how do you integrate all of these capabilities from design through the manufacturing end, through the actual operational users. And this is really about digital, if you think about it. AM is part of an overall digital Internet of Things kind of approach that says we've all got the data we need where we need it. And if that happens, I think you have the ability to truly transform how quickly we can field new capabilities and provide the operational side of the house the ability to update things on the fly as they need them, depending on the mission.
So we're really fortunate. We have some fantastic guidance from the Commandant's planning guidance, where we have been told we must continue to seek the affordable and plentiful at the expense of the exquisite and few when conceiving of the future amphibious portion of the fleet. So within the Marine Corps, we really see AM as being able to provide bona fide capabilities. And if you're able to see the photos that I compiled in the single slide, you're seeing that we're talking about, no kidding, expendable ship-to-shore connectors, mobility, counter-mobility, and survivability structures that very much, align with the CPG. So again, it's really bona fide capabilities as a means to rapidly reconstitute the force, and that's really where we see AM in the Marine Corps.
One last quick thought I'd like to add on that last question about the direction as we look forward, right? And in terms of S&T, we really want to push the bounds of what we can do and where we want to go from a platform, from a warfighter perspective, to meet the needs for all of you folks from the SysComs, right? We have efforts related to rapid qualification certification with quality made. We're looking at new material sets, exploration of new materials capabilities, and I think that's a really great way for us to continue to push the envelope. And as we provide some of those fundamental understanding and push that S&T, I think part of it is making sure that we have tools for folks to push in the design space as well for what that next gen really looks like. And so I'm certainly excited as I often engage in conversations with y'all on the phone about the hurdles you face, because from my perspective, that's an opportunity where we can really push the bounds and start to tackle some of those problems.